Secure coding in C++ is crucial, especially in applications where reliability and safety are important. This tutorial series will explore best practices for writing secure C++ code, focusing on avoiding common security pitfalls. Buffer overflows occur when a program writes more data to a buffer than it can hold. The primary risk of a buffer overflow is that it can override adjacent memory, potentially leading to data corruption, crashes, or exploitation by executing arbitrary code. Buffer overflows often occur with arrays, especially character arrays, C-strings. Since C++ doesn't automatically check array bounds, it's possible to write past the end of an array. Here in this example, strcopy is used to copy a string into buffer. However, the source string is longer than the buffer's capacity, leading to overflow. There's no check on the length of the input string, making this code vulnerable. So what kind of mitigation strategies we can follow to make our code more secure? So the first thing is boundary checking. Always check the length of the data before copying it into a buffer. Functions like strncopy, snprintf, or string in C++ help in managing this kind of issues. Now here's a safer function for you. strncopy can be a safer alternative because it allows you to specify the maximum number of characters to copy, thus helping prevent buffer overflows. In this code, strncopy is used to copy a maximum of size of buffer -1 characters, ensuring that the buffer isn't overrun. The last character is set to \0 to ensure the string is null terminated. However, modern C++ encourages the use of string or C-style strings, which manages memory automatically and reduces the risk of buffer overflows. Using string eliminates the need for manual memory management and makes the code safer and more readable, of course. If you have a different case, like for non-string data, the vector can be used. It automatically resizes and manages memory, making it a safer choice than row arrays. Here, this example demonstrates how vector can dynamically grow, ensuring safe memory management and preventing buffer overflows. These examples illustrate how to mitigate the risk of buffer overflows in C++ by using safer functions like strncopy and modern constructs like string and vector. Adopting these practices enhances code safety, readability, and maintainability, crucial for developing secure C++ apps.